Hello children, this is ninth standard physics, chapter 10, gravitation. Any object, let us consider a ball. When a ball is thrown upwards, the ball reaches a certain height and then falls downwards. This is mainly due to the gravitation. So in today's class, let us learn about gravitation, the universal law of gravitation and its formula, and some of the basic terms used in gravitation such as free fall and acceleration due to gravity, and a problem based on gravitation. In the beginning, let us learn about universal law of gravitation. To understand the universal law of gravitation, let us consider two objects A and B. The object A attracts the object B. In the same way, the object B attracts the object A with the force that is proportional to the product of their masses. Let us consider the object A has a mass m, capital M, and the object B has a mass small m. This is represented in the form of an equation, and this equation, let us write it as equation 1. And the same force is inversely proportional to the square of the distance between them, and it is written as force is inversely proportional to 1 by d square. Let us write this equation as 2. The meaning of proportional and inversely proportional means that as the force on the objects increases, their masses also increases. As the force on the objects decreases, their mass also decreases. And inversely proportional means that as the force on the object increases, the distance between the two objects decreases. On the other hand, as the distance between the two objects increases, the force acting on the objects decreases. On combining these two equations, we will get the universal law of gravitation. That is, the force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. In order to remove this proportionality symbol, let us write a equality mark and write a constant g, which is called as the universal gravitational constant, and hence the formula of the universal law of gravitation will be equal to force is equal to g, that is universal gravitational constant, into product of their masses divided by d square. D is the distance between the two objects. This formula is used to find the magnitude of the gravitational force between the earth and an object on the surface of the earth. This universal law of gravitation had successfully explained several phenomena such as the force that binds us to the earth, the motion of the moon around the earth, and the motion of the planets around the sun. The next topic is free fall. We have learnt that the earth attracts the object towards it. For example, take a stone, throw it upwards. It reaches a certain height and then starts falling down. This is mainly due to the gravitational force. Whenever object fall towards the earth under the gravitational force alone, we say that the objects are in free fall. The next term used in gravitation is acceleration due to gravity, which is represented by a symbol g, small g. While falling any object towards the earth's surface, there will be no change in the direction of the motion of the objects. But due to the Earth's attraction, there will be a change in the magnitude of the velocity. Any change that involves in velocity is called as acceleration, and hence whenever an object falls towards the earth, an acceleration is involved. This acceleration is mainly because of Earth's gravitational force. Therefore, this acceleration is called as the acceleration due to gravity, due to the gravitational force. And this acceleration due to gravity has a constant value that is equal to 9.8 meters second square. Let us solve a problem which is based on gravitation. A stone is released from the top of a tower of height 19.6 meter. Calculate its final velocity just before touching the ground. Initially, the stone, when it is released from the top of the tower, the initial velocity value u, that will be equal to 0. When it is released from the top of the tower of height 19.6 meter, we have to find out the final velocity that is equal to v just before touching the ground. From the equation of motion, we have an equation called v square minus u square equal to 2as, where v is the final velocity, u is the initial velocity, a is the acceleration, and s is equal to distance. On rearranging this equation, we get v square is equal to u square plus 2as. Now, to solve this problem, let us replace the acceleration term using acceleration due to gravity, that is equal to g, and s, distance by height h. Therefore, the equation becomes v square is equal to u square plus 2gh. On substituting the values to these physical quantities, we need to find out the value of v, that is final velocity, which is written as v square is equal to u square, that is initial velocity value is equal to 0, plus 2 into the acceleration due to gravity has a constant value that is equal to 9.8 into height is given, that is equal to 19.6. In the next step, v square is equal to 0 plus, on multiplying 2 into 9.8, we get the value equal to 19.6 into 19.6. We have to calculate the final velocity, that is equal to v equal to root of 0 plus 19.6 into 19.6, we shall write it as 19.6 whole square. In the next step, v is equal to the square root and the square get cancels. The remaining value will be equal to 19.6 meter per second. Therefore, the final velocity just before touching the ground will be equal to 19.6 meter per second.